Have you ever stopped to think about where your breakfast orange juice actually comes from? 1/3 of every single bite of food you eat relies on a single, fragile biological process: pollination. But with global bee populations declining at an alarming rate, what happens when nature's ultimate agricultural workforce vanishes? In places like Florida, this isn't a hypothetical question, it's an immediate crisis. The state's massive citrus industry spans over 400,000 acres, home to more than 50 million orange trees. During the hypercritical 2-week bloom window, these trees require trillions of individual pollen transfers to bear fruit. Manual labor simply cannot scale to meet this demand, and traditional methods are falling short. Today, AgriHubTech will take you inside the high-tech orchards where autonomous swarms of AI-driven microdrones are taking over the skies to save our crops. We'll explore the insect-sized robotic engineering, the genius swarm algorithms keeping them from colliding, and how they identify individual blossoms at 30 miles per hour. All of that coming up in this video. Let's get started. To understand why we need robotic bees, let's look at the scale of the biological bottleneck. In a typical Florida orchard, a single acre contains hundreds of thousands of blossoms. Honeybees have spent millions of years perfecting cross-pollination, brushing against male anthers and transferring sticky pollen to the female stigma. It's a masterpiece of natural engineering. But as bee populations face unprecedented pressure, farmers are in a desperate race. Some use tractor-mounted blowers to spray pollen, but over 95% of it ends up on the grass, completely wasted. Hand pollination is precise, but painfully slow. To hand pollinate one mid-sized orchard, you'd need thousands of workers working around the clock. That's why engineers turned to biomimicry, the practice of copying nature's designs. They studied honeybees under high-speed cameras, analyzing how their wings generate micro-vortexes of air to pull pollen, and how their bodies carry a natural electrostatic charge. But how do you recreate millions of years of evolutionary design using plastic, silicon, and copper? The answer lay in a breakthrough in micro-robotics. These microscopic drones weigh less than a single gram. To put that in perspective, one robotic pollinator is lighter than a standard metal paperclip. Yet, packed inside this tiny carbon fiber chassis are 4 independent brushless motors, a micro battery, and a high-resolution camera. Building a flying machine this small is an incredible feat, but the real challenge was copying the bee's fuzzy body. How does smooth plastic grab microscopic pollen without destroying delicate petals? Engineers applied a specialized liquid crystal gel to horsehair fibers on the drone's underside. This gel generates a permanent electrostatic charge. When the drone hovers over a flower, its propellers generate a small voltage, causing sticky pollen to jump off the anther and stick to the gel-coated pad with 0 damage. But capturing pollen is only half the battle. How do thousands of these machines navigate a chaotic orchard, work together in the breeze, and avoid crashing? The answer lies in a mathematical model copied from a completely different animal. To coordinate thousands of independent drones as a single unit, programmers turned to how flocks of birds and schools of fish move, creating an AI-powered decentralized swarm mind. Traditional drones rely on a central computer, which would crash trying to manage 10,000 units. Instead, each robotic bee operates on 3 simple rules: maintain a minimum distance from neighbors, match the average speed of the swarm, and move toward the center of the bloom. This allows the swarm to flow through the orchard like a fluid, wrapping around branches and adjusting to wind. But how do they find the right flowers? This is where the drone's microscopic camera and AI processor come alive. Using deep learning computer vision, each drone scans the environment, instantly distinguishing between closed buds, dead leaves, and perfectly open blossoms. It's like a supercomputer on wings. The drone calculates the exact flight path, hovers for a split second to transfer pollen, and moves on. At this speed, a single swarm can pollinate an entire orchard with over 90% efficiency. This technology is more than just an engineering triumph. It's a massive leap forward for global food security. As ecosystems face mounting challenges, AI and agricultural engineering are stepping up to bridge the gap. These robotic pollinators aren't designed to replace biological bees, but to act as a crucial safety net, safeguarding our food supply and supporting farmers when nature needs a hand. It's a stunning example of tomorrow's technology preserving today's agriculture. And unlike biological bees, these mechanical workers absolutely won't sting you if you walk into their path. What do you think about robotic bees taking over our fields? Let us know in the comments below. If you want to stay updated on the future of industrial tech, don't forget to like, share, and subscribe to AgriHubTech. Thanks for watching, and we'll see you in the next video.